Today we're going to talk about parabolas, and we're going to talk about parabolas that are at the origin and that actually aren't at the origin too. So let's go ahead and look at these four different graphs on the left-hand side to kind of see what's going on when certain things change within the equation. So looking at our first graph right here, I'm going to just kind of substitute in some numbers and graph what's going on. So if I substitute in, let's do -2. So if I substitute -2 in here and square it, I get 4. So at -2, I would be at 4 on y. Let's substitute in -1. -1 squared is 1. Substituting in 0, 0. Substitute in a +1, 1. And substitute in a +2, we're at 4. So this is what our function would look like. Let's go ahead and look at this one here because I noticed that the squared is now on the y instead of the x. So if I substitute a -2 here and square it, I get 4, right? But x would be 4 and y is -2. So what about if I substitute a -1 for y and square it? I would get 1. So we would be right here. If I substitute in 0 for y and square it, I get 0. And then as I go through, this is what I would get here. So what's happening is when the x is squared, it looks like it's opening up, and when the y is squared, it looks like it's opening to the right. Well, let's go down here. So what we've done is we've changed from here to here, is we've put a -1 right here to see what would happen. So we're going to do this the same way. So if I put in a -2 here and square it, I get 4. But then I'd have to divide by -1, and I would get -4. So this would be -2, -4. And then if I put in a -1 and square it, I get 1. But then I divide by -1, so I get -1. And if I go through in this fashion and make like a little chart or a table, if you want to do that, that's fine. This is what I'll get. And then over here, if I do the same thing over here, the same thing is going to happen here. It's going to flip around on me. So if I substitute in those values, you're going to get something that looks like this. Now I'm doing these four graphs so we could just basically talk about what's going on. So it looks like if the x is squared, if this number is positive over here in the front, it opens up. And if this x is squared and this number right here is negative, it opens down. And if y is squared but the number in front of this right here is positive, it opens to the right. And if y is squared and this number over here is negative, it opens to the left. Now technically there's something called a p-value, and you would set 4p equal to -1 to solve it, and we'll be doing that in a second because p actually kind of tells you which way it goes. But I know that you can kind of eyeball it too and tell me if it opens up, down, or left, right. So as we go through these problems, if you can just kind of look at it and tell, that's totally fine too. So let's go ahead and fill this in. If x is squared and the p is positive, so if x is squared and p is positive, this is going to open up. And then if x is squared and the p is negative, which would be what's happening down here, this is going to open down. If your y is squared and the p is positive, it opens to the right. And if your y is squared and your p is negative, it's going to open to your left. Okay? So let's practice this a little bit down here. It says find p and determine the direction that each parabola will open. Now, p value actually tells you which way it opens. So do you see how what they've done here in these general equations, and we haven't used the h and the k yet, that's going to be our vertex, and all these problems are vertex with 0, 0. But let's go back to this. Right in front of whatever term is not being squared will be a number of some sort, some constant. And you're going to find p by setting 4p equal to that number and solving. So let's look at number 1. So in number 1, what we want to do first is we want to get our squared term alone. So let's go ahead and subtract 3 from both sides. So I'll have x minus 3 equals -2y squared. And then I want to get y squared alone. So what I want to do here is I want to divide both sides by -2. Now, there's a little something I'm going to do here, and it's because it's going to make it easier for us later so we don't have to factor it out. What I'm going to actually do is multiply both sides by -1/2. Because if I do that, Now it's going to be a lot easier to find that p-value that I'm looking for. These would cancel and you get y squared. So whatever number is here in front of this, you set your 4p equal to. Now, looking at this looks a little different than the other 4 we just did because our vertex is not at the origin. It's not at 0, 0. Our vertex in this one would be at 3, 0, okay? We're going to talk about that a little bit when we graph. But let's go ahead and find that p-value first. So since this right here is equal to 4p, I'm going to write that down. And then to get p alone, I would divide by 4 on both sides. So if I divide by 4 on both sides, I get negative 1/8. And since that's negative, and my y is squared, okay, if y is squared, it's left or right. But since that's negative, it's going to open to the negative way. Opens left. There you go. Okay, so let's go ahead and let's look at 3. I'm going to look at 3. So the first thing you want to do is you always want to get your squared term alone. So what I'm going to have to do here to both sides is divide by 5. Or essentially what you're doing is you're multiplying both sides by a 1/5. So I'll have 1/5 x equals y squared. So I want to find my p-value. So whatever's in front of the term that's not being squared, we set equal to 4p. And when I do that, I have 4p equals 1/5. Then I divide by 4 on both sides, and I get 1/20, like that. Now, my y is squared here, so that means it's either going to open left or it's going to open right. But since my p-value is positive, it opens in the positive way. So this is going to open to the right. So it opens right, like that. Let's go ahead and talk about number 4. So on number 4, remember, we want to get the squared term alone. So what I'm going to do here is I'm going to multiply both sides by a 2 like this. So 2y then will equal x squared. Now, it's x squared, so it's either opening up or it's opening down. So let's find our p-value first. So if 4p equals 2, and we divide by 4 on both sides and reduce, we'll get p as 1/2. So it's either opening up or down, but this is positive, so it opens in the positive way, so it's going to open up. Just like that. I'd like you to try number 2, bring that to class, and we'll discuss it the next time we see you. So go ahead and do number 2, bring that one to class. So down here, we're going to discuss some new vocabulary. We have a vertex right here, and then we have something called a focus, and we have this line right here, which is called a directrix. Now, I usually dash my line. In this picture, it's just a blue line, but I usually dash mine. The focus and the directrix are the same distance away from the vertex, but in opposite directions. Your focus will always be inside the parabola. Your directrix will always be on the other side. How I like to remember it is, whichever way your parabola is going, it doesn't matter if it's up, down, left, or right, the focus goes inside of it. So it's like a bowl, and you've got a little piece of food in it. So bowl and food. And then your directrix will go on the other side of it. What makes the focus and the directrix fancy is that no matter where I am on here, and I go out to here, the exact same distance it'll take to get there. Isn't that neat? It's equidistant. They're equidistant. So let's go ahead and talk about that a little more down here with the graphing, and you'll see what I'm talking about. So I have some things up here that you can do when you're graphing, and instead of sitting here reading them to you, I just left them up there for you to use when you practice it on your own. We're going to go ahead and just go through number 1, and this is basically what I'm going to be doing when I go through number 1. So first things first, let's find our p-value. Well, on number 1 here, we have to get the x squared alone. So we have to first multiply by 2 on both sides. So if I do that, 2y equals x squared. So now to find the p-value, we set 4p equal to this number in front of the term that's not being squared. So that's 2. And then when we divide, 2/4 is 1/2. So our p-value is 1/2 here. Which way does it open? Well, it's x squared, so it's up or down. And since this is positive, it opens in the positive way. So this is going to open up. What's our vertex? Well, we haven't talked a lot about it yet, but the general form of a parabola, I'm going to scooch up here, are these two equations, okay? Because there's 2 of them because some open up, down, and some open left, right. The h and the k are your vertex. Well, notice there's parentheses and all that, right? Do you notice here we have no parentheses really going on? That's because our h and our k are 0 and 0. So our vertex is going to be at 0, 0. Might as well just plot that now on my graph. The axis of symmetry we'll do in a second. Let's do the focus next. The focus is the same distance away as the directrix from your vertex. So we have the vertex plotted, and we have our p-value. So we use this p-value when we do the focus and when we calculate the directrix. Now this is going to open up. And since it opens upward, and you know what, we'll just sketch it in. I'm not going to get too crazy about that. Just sketch one going up. Your focus is inside the bowl. It's like a piece of food inside a bowl. So I'm going to go up a half, and I am going to plot a dot. I'm going to go ahead and zoom in a little bit here. There we go. So I'm going to plot a dot right there. This right here is my focus. I tend to label things like that whenever I'm graphing them. So what are the coordinates of that focus? Well, it's at 0, 1/2. The directrix is the same distance away, but it's underneath it. So we're going to go underneath here and about at 1/2. Mine's not perfect, but that's okay because I'm going to write the equation. We put in the directrix. Now the directrix is a line, and this is a horizontal line. So that's y equals -1/2. You have to have the y equals because that makes it a line. And the last thing we're going to do is the axis of symmetry. Now think about what symmetry is. It splits something perfectly in two, correct? So in this picture, our axis of symmetry would be right here. Now the equation of this line, it is a line, it's vertical. It's going to be x equals 0. So there's our axis of symmetry. So we have everything nice and graphed there. This one's an easier one because the vertex is 0, 0. They get a little tougher whenever the vertex isn't 0, 0, but it's nothing that you can't handle. You know what? Let's do this. For number 2, we're going to discuss this one in class. If you want to try it, you can, but you're not required to try it. I would like to talk about it in class with you since it's not at the vertex. So this problem up here, this number 2, make sure you do have that done for class, but then this number 2 down here, we're going to discuss in class together to make sure you understand it. Thanks for listening. Have a wonderful rest of your day.